Hello, my name is Damian. I'm an Android engineer at Onefootball, and today we will look at navigation in modular applications with deep linking. I put some code snippets on these slides, but since it's a lightning talk, there might not be enough time to look at them completely, so feel free to check out the slides afterwards and dive in deeper. So first, we will take a look at modularization and the different kinds of modularization, some approaches. I think all of us are pretty familiar with this one, just having a single module for the app where all the code lies inside all the resources, so everything is accessible from everywhere. The only scoping you can do is pretty much through Java modifiers or packaging. Compilation is also module-based with Gradle, so if you change one thing, you have to recompile the whole module. If we switch a bit further, we see modularization by layer. The layers are, as always, up to discussion. These are just some examples. Here we can work on a need-to-know basis, so not every layer needs to know all of the others. Our app doesn't care about DTOs, for example. It's easy to reuse the layers if we want to target different systems, like a Wear OS app or a TV app. If we go a bit further, we can modularize by feature. This allows us to work in cross-functional teams. We can work with less conflicts. Maybe we will have a core layer with reusable things that we need everywhere so we don't duplicate the code. And if we want to go even further, we will create a matrix. We will just do all of it. We have our app module on the top. We may still have a core layer, and we will have our feature modules, and even our feature modules will be separated into smaller modules depending on the layers. This gives us a lot of benefits with incremental compilation, but also has some drawbacks that you need to plan it a lot more. You need to know where to put stuff, how to use it, and it's easy to kind of get lost in the modules once you reach triple digits. Next up, after covering the basics of modularization, we will take a brief look into navigation in Android apps. This will also just be a rough overview of the different navigation patterns we have. So first off, multi-activity and intents. It's pretty easy, just create an intent, pass in the new activities class, and start the activity. The next one, we can replace fragments. We just create new fragments, kick out the old ones. Maybe we have multiple fragments in an activity. It just works. Sometimes, most of the times. The next one is if you want to work with views instead of fragments or activities. Well, you still need an activity as a host, but you can juggle around view groups and views. You can also do that. There are some frameworks like Conductor or Scoop, even though that's kind of deprecated by now, that will assist you here. But this is also a legit thing to do. And then we have the Android X navigation component, which also wants to take care of your navigation needs. Here you simply define the navigation actions in your XML file. They belong to a fragment, for example, and they just define a different fragment as a destination, and you just trigger them through a navigation controller. Next, we will take a look at deep linking in general, how deep linking works, what is a deep link. Links are pretty well defined. There's a URI scheme that has been around for quite some time now. In the scheme, authority and path are required, the rest is optional. And if we want to apply this to, for example, the web, the scheme is HTTP or HTTPS, but we can also do the same for our applications by just using our own scheme, for example. We can also override or do pattern matching with HTTP links to redirect the user into our app. But in this case, we will take a look at custom schemes. So in this case, I defined my app scheme for my app. And we can also add more information to the deep links. For example, here we look for a profile with an ID. That works as well. You can also use query parameters or fragments in the URI. So it works just like a normal URI works. If we look at deep linking in action on Android, there are also multiple approaches to this. For example, you can do it manually in the Android manifest. You can simply add an intent filter to the activity you want to expose. You can specify multiple of these for if you want to support different types of URIs. But in the long run, you would end up with a lot of them. And maybe you want to show a splash screen, so maybe this is not the best solution in terms of scalability. The next approach would be to have a single activity as a catch-all activity, which hosts, here I call it a deep link processor, but in theory it's just, it just keeps track of different deep links that you support and the endpoints where it redirects you. So for this, if we have a single activity, we still just send out an intent with a URI, the same as with the manual approach. In the catch-all activity, we parse the deep link. We just forward it to our list of processors, and so each processor takes care of a single deep link endpoint, and here we just see which one matches it, which one has the capability of handling it. After looping over the processors that we have available, and when we find a matching one, we just pass on the deep link, and our processor will, in its own scope, take care of parsing it, extracting data, and forwarding it, and starting the activity or triggering another navigation action if you want to replace a fragment or if you want to replace views. This is all possible. There are also libraries that will help you take care of this. For example, Airbnb published the deep link dispatch library. It's a couple of years old already, but it still works. It's annotation based, so it works in compile time. It generates code. It basically generates the catch-all handler for you. In this approach, you still need to define your own activity because they decided to not provide the activity and merge it from the manifest. So it works pretty similar, except that you don't need to manually do the deep link matching anymore and the extraction of data. The Android navigation component also supports deep links. It is, again, pretty similar, pretty easy to set up. You just modify the XML, you just add a deep link tag, and you can also add different schemes, different endpoints. You can also allow placeholders. You can pass in data and extract it later on. Next, we will take a look at modularization and navigation. There are some things to keep in mind when combining both of these. So we will skip the single module because that's pretty obvious. We have access to everything and we can just take care of our navigation needs. If we look at modularization by feature, it gets a bit more complicated. To be able to navigate from one feature to another one, we would need to add a dependency. And if we do this for every single navigation graph or inter-feature navigation action, our dependency graph gets quite big and kind of out of hand. So it's not the cleanest solution. The same will obviously happen with the matrix that I showed earlier, because it's basically like it's based on the modularization by feature. It just extends it. So the same drawbacks apply. If we take a look at dynamic feature modules, things get a bit more complicated, but it sort of points us into a cleaner solution, or it forces us to do a cleaner solution. So we will take a small detour and look at what exactly is changing when we introduce dynamic feature modules, because I'm also not sure how familiar everyone is with the dynamic features. Dynamic features have been introduced as an extension of app bundles, basically. App bundles extract resources and build different APKs based on the device configuration and the user configuration. Dynamic feature modules do the same, but with code modules. So instead of extracting resources, it is extracting actual code and loading that back in runtime. So this has some implications on how we can structure our code and how we can do navigation in our app. The app or the base module and even feature modules don't know about dynamic feature modules in compile time because they are not loaded, obviously. So they learn about them in runtime. So we can't really reference things like classes or create fragments by calling a static method or constructor or whatever you prefer. For this, we would need reflection. And with reflection, these things get a bit more messy. So we need to add the fully qualified class name to create our intent. We need to do the same for fragments. If we want to call a method, a static method, we need to find it first on our potential fragment class, and then we can execute it and create it. So starting from here, let's take a look at how deep linking can help us with modularization, and especially if we keep the dynamic feature modules in mind. If we have an app that has a lot of dynamic modules, so not a lot of features are available in compile time, we don't really know where we can navigate because it might not be loaded. So if we do a reflection-based approach, then we need to check if the class is loaded, if it's available, if we can do it, if we can execute it. And all of this has to be done with the fully qualified class name, so it's a bit messy, as I said. So this also creates tight coupling between the implementation of different screens in a place where with the dynamic features we intend to actually remove this tight coupling because we want to create a component that can be loaded in runtime and that can also just not be there. So with this we are kind of mixing these two things, the decoupling and the tight coupling. So if we instead think back to deep links, they are implementation independent. They work on different levels. They work in web, in apps, in other places as well. You can just define where you want to use them and just use them. They are descriptive if you want them to be. They can be human readable. If we use a deep link for navigation here, we don't really care if it's an activity or a fragment or which one it is. These are all implementation details that we don't really want to care about. So we just basically fire off our intent with a deep link and someone is catching it. Someone can handle it. Which one of these we will load to fulfill a certain task in our app. We don't need to know which one is actually there. We can simply fire off our intent with our deep link, and the right one that is loaded will handle it and will start the task. We also don't care about our specific implementation of navigation patterns. So as you can see here, for example, in the first one, the module simply defines an intent filter and uses that to parse the deep link or the intent with the deep link. And you could also exchange it with the Android X navigation component if you prefer. It can also handle deep links. So this is implementation independent on both ends, basically. We don't care who we are targeting, who will fulfill the task, and we also don't care who is going to receive our intent and parse it. If we go from here, there are a lot of things that are still a bit open. The navigation component will most likely, as far as I know, also support dynamic feature modules sort of out of the box at some point, but I don't think there's much out in the open about that yet. So we will see what happens. I have added some links to the slides, so feel free to check them out afterwards. These will just give you examples or pointers or lessons learned, basically. And that's it. Thank you very much.